Hey everybody, welcome to this series of videos on building Tetris. So Tetris is a great game for an introduction to game development because it's simple. There's not a lot of, there's no physics, there's not a lot going on, there's no character animation, but you still have some logic. So you still have a fair amount of logic. You have pieces that are interacting with each other. There's some collision detection with the walls and the floor. There's enough going on to make it interesting. So I thought I'd make this series. I actually saw this video on YouTube last week or a couple weeks ago, and I sent it to a friend of mine, and I was like, oh, this is cool. But there's no talking during this video. So like the video, it's like, he's showing off the great sound of his keyboard, and it does sound fantastic. He's got this nice looking keyboard, but he doesn't explain what he's doing along the way, which is totally fine. He's under no obligation to. But when I was talking to my friend about this, I was like, have you ever done game development before? And he said he hadn't. And so I thought this might be a fun thing to do a series where I kind of explain the basics, the very basics of game development. So I'm not a professional game developer. I am a professional developer, but I just have done a little bit of game development in my spare time. We're going to be working on the HTML5 canvas. So the canvas gives you some interaction. It's really different from working with the DOM, though, with like regular DOM elements. You are manipulating pixels directly, basically. You're kind of moving things around the canvas on your own, keeping track of positions and rendering things in a loop. So let's get started. Oh, and also I didn't watch the video all the way through, so I don't really know. I saw a few things at the beginning, but I don't really know how he builds it. So I'm gonna just build it my own way. So I'm not, the way that this is being built is not going to be the same as him. All right, let's get going. So I'm going to close out these, and I have nothing here, nothing at index. So I have a fresh folder. I'm going to just add an index HTML and JS. I'm going to set up linting and prettier. Okay, so now I have a basic, just not much in here, but I got index HTML. So if I, there we go. So if I start this, we're going to have an HTML file, just something on screen. All right, there's our index HTML. That's it. So we still don't see anything here. I mean, we see a blank page now, but no canvas yet. So then let's hop over to our JavaScript file. And let's start getting some access to the canvas here. So we'll get a reference to the canvas. And we will get the context off of that canvas, which we'll use later. And we'll get, what else do we need? We're gonna give it a height and a width, and we're gonna render this canvas. So we got canvas. Oh, let's define some height and width constants first. And we're going to make it 10 by 20, which is the typical Tetris board. Oh, these are backwards, height and width. So height should be 20. And then we're going to also make a tile size of 10. So so each of our squares is going to be, 20, not 10. So each of our squares is going to be 20 pixels. Tile size is 20. And so then we will make the canvas width and height match these. Okay, and then we will fill it with black. And I think that should show us something, right? Yeah, a little tiny canvas up here. So why is this so small? Well, it's because it's only 10 by 20 pixels. So any numbers that you have in here are just going to be pixels. So we need to multiply this by the tile size. So, you could do this a number of different ways. The reason why I'm multiplying this by the tile size is because I kind of want to keep the values when we're moving things around, X position and Y position. I want to keep those as straightforward as possible. So I don't want to worry about the tile size while I'm moving positions around. I want to just have that be like, you know, the index of the whatever array I'm working with should be that number, not like that number divided by tile size. So it's basically separating out your position in your update from your render. So we have our canvas, and now this should be full-size canvas. There we go. Great. What am I going to do next? So next I'm going to make a game loop. So we're going to have a really basic game loop, just to kind of show you what it is. So I'm going to be using window.requestAnimationFrame, or just requestAnimationFrame. And you can do this a couple different ways. You could use set timeout with a recursive set timeout call or a set interval. requestAnimationFrame is kind of the it's the best way to keep it running at 60 frames per second. And you can do some things pretty simply. We're not going to do them today, but you can do some things to keep it running the same frame rate no matter how fast your computer is running. So so let's do this. So we're going to create a loop function. And we are going to, in our loop function, we're going to call requestAnimationFrame and pass our loop into requestAnimationFrame. And so then that will just recurse. So this requestAnimationFrame's callback gets an elapsed, or sometimes it's called timestamp. So basically this is how much time has elapsed since the start, right? So if we say, since like this was first called, so if we say, we'll kick this off with a requestAnimationFrame. And if we log out elapsed, we're going to see that it is just ticking up 1 second at a time in milliseconds. So I'm going to stop that from looping, or I'm going to cancel this loop going on. So that's fine. So this is our basic loop. It's just a recursive function. And what we want to do in here is we want to have a render, like render world and update world. We don't want to define them in here. We want to say we want to call render world and update world. So these functions are basically going to, and actually we want to update before we render. So we want to update before we render because we want to move all the entities into play. I mean, in this case, we just have really one. We have like the falling piece. Towards the end, we'll update the floor. But, and by floor, I mean the pieces that have already fallen. And but we want to update the piece before we render it in case we need to make adjustments to the position of the piece before displaying it on the screen. So for example, like collisions are kind of why you want to update before you render, because if you collide with something, you want to, in our case, if we collide with the wall, we want to bump that piece back into its original position before we render it, because we don't want to render it off screen. Okay, so update world, we'll define these functions. Okay, so our update function is for moving things, and our render world function is for drawing things. And when I say things, I mean layers and entities. In GameDev, you usually talk about entities. So that would be like your player, your enemies, your things you pick up. A lot of things, those things are referred to as entities. And so if you have like an array of entities in your render world, you can just say entities.render, and every entity should have a render function exposed on it. So in this case, we just have a background render. So in our case, we're going to have layers. We're going to have entities, but we're also going to have a few layers. So we'll have a background layer. We will have eventually a floor layer, but right now we're just going to have a piece layer. Okay, so we're going to render the background and the piece, and we're also going to update the piece on each update. And so, so now we need to have a background and a piece. So we're going to have some factory functions for those. Okay, so we have our background and our piece. We need to expose an update, or we just need a render on the background. And our piece will get a render and an update. Okay, so in our background render, let's do this first. We are going to, no, you know what? I'm going to do the piece render first. So in our piece, we are going to render this to the screen. So we're going to use our context to render something to the screen. So we'll say context.fillStyle. So first you need to tell the context what you want to fill, or how you want to fill the thing that you're going to be drawing. And then you'll say fill rect, and this is a function. So fill rect is going to draw a rectangle on our canvas, and it takes an origin point XY and a width and a height. So our origin point, we're going to have this be width divided by 2 for the X and 0 for the Y. And then these will actually be positions when we create those, but for now we'll just have it be width divided by 2 and 0. And so this will be tile size for the width and height. Okay, so I think if we do that, nope, nothing yet. So let's see, what do we need to do here? Do we have, yeah, because we're not looping this yet. Okay. That's fine. I can get rid of that for now. Nothing. Piece is not a function. What are we calling piece? Piece. What? Wait a minute. Piece.update. That's what we want. There we go. All right, we got a red square there. It's not in the middle of the screen, and so this is what I was talking about, where we're going to need to adjust the render functions by the tile size, but we want to keep these adjustments in the render function rather than in the update function. So our updates are going to be much more complicated, where we're going to be moving things around the screen. Our render functions are pretty simple. They're just like draw the thing at whatever position it's at. So let's actually give this a position now. So X and Y position, and we're going to multiply this by the tile size. Okay, so now that should be in the middle of the screen. Great, and there it is. Okay, so we've got that rendering. The next thing we want to do is start dropping it down the screen. So in our update function, we are just going to move our piece, our position.y, by 1. And we are going to do that. So if we save this, a couple things are going to go wrong. So for one thing, it's moving really fast. We want to slow it down. For another thing, it's leaving a trail behind it, and it's leaving a trail because we aren't rendering the background. In our background, we basically, like, if you render something, it doesn't get cleaned up automatically. You kind of have to manage that yourself. So in our background layer, we're just going to clear that out. So we'll say context.clearRect, and we're going to say 0, 0, width and height. So that's going to clear the whole screen on every frame, and we need to make sure that we're doing that before the piece renders. But why? Let's see, we're not doing that. Clear rect background render. What am I doing wrong? Clear rect 0. Oh yeah, it's the tile size again. There we go. That's better. So still moving really fast, and that's because it's moving at 60 frames per second. So we want to slow this down. We only want to call update if a second has passed. So so we want to render on every frame, because if we hit left or right, we want it to re-render more often than once per second. But if we're just leaving it alone, it should tick down the screen once per second. We also want to be able to control that speed. So yeah, we'll do that. So we'll say if second has passed, and I'll define that in 1 minute, we want to update the world. And how do we do that? So what second has passed? Okay, so now we're going to want this elapsed, and we're going to want start time. Start time is going to be 0. And so what are we going to check? So second has passed is going to be elapsed minus start time greater than 1,000, right? So that'll be like, check if a second has passed, and if it has, we want to update the world. Otherwise, we won't update the position. So we'll render it, we just won't update. And now it's like it's waiting a second and then it's dropping. So something else, we need something else here. Basically, we need to reset start time to be elapsed. If it's past a second, we want to say elapsed, or we want to say start time equals elapsed. And so now this will reset elapsed, and it will now check every second, and then it'll reset this. So it'll call this once a second. It'll only call update world. Okay, so that's a basic game loop. So let's do one more thing here. Let's set this up so that we can have this 1 second be variable. So we'll say 1,000 divided by, let's see, what do we want here? Divided by like speed, right? So if speed is a higher number, this will update more often. It will update, once every, if speed is 2, it'll update every half second. If speed is 10, it'll update every 100 milliseconds. So we'll have let speed equals, we'll start it off at 1, and we'll call this default speed. And so speed is going to be 1, and I'm going to set that up here. Default speed is 1 because we are going to want to when we press down on the down button, we're going to want to speed up, and when we let go, we're going to want to go back to the default speed. So I just didn't want that to be like a magic number 1. And yeah, so I think that will do it. That'll give us a little bit of flexibility to change that speed. All right, so I'll see you in the next video.